It's the math guy, Steve. Let's try this word problem. This one here says Shauna can pour a large concrete driveway in 6 hours. Dan can pour the same driveway in 7 hours. How long will it take them if they work together? So we have to know a little bit about how we find work. Okay, so our work is just the work rate times the amount of time it takes us to do that work. Okay, so here we'd say W equals R times T. Now, each of them has a different work rate, right? So Shauna can pour a large concrete driveway in 6 hours, right? So if it's one large driveway, that'll be our work. The rate is what we're trying to find, and then times the time, which is 6 hours. Got it. So our rate would be 1/6. Okay, that's Shauna's rate, right? So Dan's work rate is a little bit differently. So we still use W equals R times T, but now that W still is W1 is 1, right? One driveway. The rate is a little bit different, so we're trying to find that rate, but the time it takes Dan is 7 hours. Okay. So Dan's work rate would be 1/7. All right. Now if they work together, that means that we have a different rate, right? And so to find that total rate, we just add those numbers. Okay. So 1/6 plus 1/7. All right, to add these, we find a common denominator of 42. Okay, so this would be 7/42 plus 6/42. All right, so then we can add the numerators. That gives us 13/42. So we have our total work rates. Now it says how long will it take for them if they work together? So work equals rate times time, right? But we're still doing that one driveway. Got it. Equals, this is our new rate, is 13/42. And now we're trying to find the time. So to solve this for T, we would multiply by the reciprocal or divide by 13/42, which gives us 42/13 is the time, okay? Which is about 3.23 hours, okay? So that would be the amount of time it takes if they work together. So clearly, working together is better. Always remember, math is everywhere.